In this video, we'll talk about function notations, exercise. So if they given you a function, first of all, let's talk about domain. How to find domain of each function. So they given you a function, fx equals to negative 5x plus 1. So you're starting with, you will assume that x domain is the possibility of x, right? You will assume that x can be anything except for what? So for a linear function, x can be anything. So that means the domain should be all the real number. And then when it comes to radical function, which is fx equals to square root of 5 minus 4x. So we know that in a radical function, a square root, everything under the square root, this part, it has to be greater than or equal to 0. Because this negative 4 is no thanks. It's not a real number. When we talk about the solution of x, all the possible of x, we only discuss about the real number. We don't discuss about the complex number. I mean, yes, you might say, hey, this is equal to 2i, but we don't want the i because when we talk about domain, we only discuss real numbers. Okay, so I have what? Everything inside the radical, which is the square root, has to be greater than or equals to 0. So I have what? We solve for x, we have negative 4x greater than or equals to negative 5 divided by negative 4 on both sides, and then you switch the sign. So I have x less than or equals to 5/4, but positive, because negative negative you will have a positive. So another example would be if I give you fx equals to x minus 16. Again, you see the radicals. The first thing you think about is, hey, everything under the radical has to be greater than or equals to 0. And then we solve for x. So the domain for x is x greater than 16. So you can write it as a interval form notation, which is greater than 16. That means from 16 to infinity. Okay, and then if you see a rational function, such as fx equals to negative 2 over x squared minus 3x minus 4. So this is the rational function. When you see a rational function, what things you need to be careful about is the denominator. We know that they can be 0. They can be a positive number, they can be a negative number, but not 0. So I just have x can be anything except for 0. And then we try to solve it. So we use AC method to factor it. So this is not equal to 0. When we solve it, we have x not equals to 4 or x not equals to negative 1. So if you draw it on the number 9, you will have negative 1, 4. These two x cannot equal to, that's why it's an empty circle. Other than that, x can equal to this part, the left part, the middle part, and the right part. So remember, the left part is negative infinity to negative 1, middle part is from negative 1 to 4, and then the right part is 4 to infinity. So it would be easier if you draw a number 9, not including 1, so that's why it's parentheses, not a bracket. The second interval is from negative 1 to 4, union, from 4 to infinity. Okay, what if it's a combination, such as fx equals to square root of 3x minus 12 over x squared minus 25. So we saw a rational. Again, it will be the same. So this part under the rational, under the square root, under the radical, that means what? You want 3x minus 12 greater than or equals to 0. And then you solve for x. That's from the top. So I have 3x greater than or equals to 12, x greater than or equals to 4. And then you also need to be careful about the denominator, this part. So the denominator in a rational expression, we know that, hey, I don't want the denominator equals to 0. Because when it equals to 0, the function doesn't make sense. So when you solve it, I have x plus 5, x minus 5, which is the perfect square. I'm sorry, it's the difference of a square, which is x squared minus 5 squared not equals to 0. And by the difference of square, the formula, we have x is not equals to -5 or x is not equals to 5. Now we combine these two together and see what x can equals to. So this is number 9, negative infinity to infinity. 0, 5, -5, and 4. So from the red part, we know that x can equals to -4, can equals to 4, equals to 4, and also has to greater than 4. But from the yellow part, oh, I should use different color, sorry. So this part, I'm going to use yellow. So everything, they can equals to 4, including 4, solid dot, and then greater than 4. So from 4 to infinity. And then from the bottom, we know that x can be anything except for -5 and 5. So these two, 5 and -5, has to be a circle. So now we combine all of these together. When you combine, you just find the overlap part. Which part they overlap? This part, right? Except for 5. So that means x in this domain equals to, they can be from 4 to 5, but not including 5, including 4. Union from 5 to positive infinity. That would be the domain. Okay, so the next part, I think lots of you can do that. It's called evaluate each function. So that means they've given you a function, fx equals to 4x minus 4. They want you to find f of 0. This notation means what? This means, hey, you want to substitute sub x equals to 0 into the original function. So I have what? F of 0 equals to 4 times 0 minus 4 equals to -4. So S sub f of 0 equals to -4. But if the opposite, they want you to find x if f of x equals to 16. That means what? That means the function, which is this part, because this part is equal to fx. We have our fx. Okay, let me write this. Now they tell you what? Fx equals to 16. But fx equals to what? 4x minus 4. So that means this part, I'm going to replace it with 4x minus 4 because it's equals to fx. And now we solve for x. So 4x equals to 20. So x equals to 5. So that means when x equals to 5, we have fx equals to 16. Or maybe I should say, hey, when the function fx equals to 16, we have x equals to 5. Okay, another one is you substitute a expression into fx, such as, again, let's use the sum function. Fx equals to 4x minus 4, and now I want you to find f of a. That means what? You want to replace every x with a. So I have what? 4 times a minus 4. You just replace the x with a. So if they tell you that, hey, I want to find f of 2a, that means you want to replace the x with 2a. So I have 4 times, let me use a red pen, 2a, because it originally was x, the highlighted part, minus 4. And then you simplify it, you have 8 minus 4. So another example, if I ask you, hey, f of 3x, that means what? You want to substitute 3x with x. So 4 times, everything remains the same except for the x. It's going to become 3x. And then you simplify it. I have 12x minus 4. Okay, that's it for this exercise. Let me know if you have more questions.